This is part 2 of the Fundamentals for Understanding Blockchain course. Many of the technologies we now take for granted were quiet revolutions in their time. Just think about how much smartphones have changed the way we live and work. It used to be that when people were out of the office, they were gone, because a telephone was tied to a place, not a person. Now we have global nomads building new businesses straight from their phones. And to think, smartphones have only been around for merely a decade. The diffusion of innovation theory, first postulated by Everett Rogers in 1962, explains how an idea, product, or behavior takes root in a society through different segments of a population. It starts slowly at first with the innovators and early adopters, who make up just 16% of the population. These are the intrepid individuals who see opportunities before they are there, who are willing to experiment, take huge risks, and change the status quo. After them, the innovation begins to gain traction and spreads exponentially to the early majority, who are more wary than the ones who came before, but still are eager to jump on board. They are followed by the late majority, a risk-averse and skeptical population. And finally, the laggards, the ones who are most resistant to change. At this point, the diffusion of innovation is complete. A new norm or product has achieved dominance in society. Where then should we situate blockchain on this curve? Many believe we are already in the early majority phase of exponential growth and that we are on the cusp of full adoption. I wish to temper expectations and introduce more nuance into the equation. It is important that we examine the issue of blockchain adoption from two different angles: investments and technology. On the investment front, blockchain has indeed reached the level of early majority. More and more capital, both institutional and household, is being poured into the cryptocurrencies today. In 2017 alone, the total crypto market capitalization ballooned from $18 billion to more than $500 billion. Coinbase, the online exchange for buying and selling digital currency, recently reached more than 10 million users worldwide and became the most downloaded app on the US Apple Store. From a technological perspective, however, we are still quite far behind. Firstly, there exists a dearth of talent. Blockchain developers are few and far between, and the growth of many crypto projects has been limited by the difficulty of finding qualified technologists. Secondly, there remain many technical issues that need to be ironed out, the most notable of which is scaling. Blockchain networks are still not capable of handling the high transaction volumes that could rival that of the large industries and financial institutions. Without the appropriate scaling solutions, transaction costs would be too high and the wait times too long for viable adoption. Regarding blockchain innovations and adoption, consider what's happened in just the past 10 years. The first major blockchain innovation was Bitcoin, a digital currency experiment. The market cap for Bitcoin now hovers between 100 and $125 billion and is used by potentially millions of people for payments, including a large and growing remittances market. The second innovation was called blockchain, which was essentially the realization that the underlying technology that operated Bitcoin could be separated from the currency and used for all kinds of other inter-organizational cooperation. Almost every major financial institution in the world is doing blockchain research at the moment, and 15% of banks are believed to have begun using blockchain in 2017. The third innovation was called the smart contract, embodied in a second-generation blockchain system called Ethereum, which built little computer programs directly into the blockchain that allowed financial instruments, like loans or bonds, to be represented, rather than only the cash-like tokens of the Bitcoin. The Ethereum smart contract platform now has a market cap of around $50 billion, with hundreds of projects in or headed toward the market. The fourth major innovation, the current cutting edge of blockchain thinking, is called proof of stake. Current generation blockchains are secured by proof of work, in which the group with the largest total computing power makes the decisions. These groups are called miners and operate vast data centers to provide this security in exchange for cryptocurrency payments. The new systems do away with these data centers, replacing them with complex financial instruments for a similar or even higher degree of security. The first proof-of-stake systems went live in 2017. The fifth major innovation on the horizon is called blockchain scaling. Right now, in the blockchain world, every computer in the network processes every transaction. This is slow. A scaled blockchain accelerates the process without sacrificing security by figuring out how many computers are necessary to validate each transaction and dividing up the work efficiently. To manage this without compromising the legendary security and robustness of blockchain is a difficult problem, but not an intractable one. A scaled blockchain is expected to be fast enough to power the Internet of Things and go head-to-head with major payment middlemen of the banking world. The innovation landscape represents just 10 years of work by an elite group of computer scientists, cryptographers, and mathematicians. As the full potential of these breakthroughs hit society, things are sure to get a little weird. Self-driving cars and drones will use blockchains to pay for services like charging stations and landing pods, and international currency transfers will go from taking days to an hour and then to a few minutes with a high degree of reliability a higher degree of reliability than the current system has been able to manage. Blockchain technologies provide new ways for value exchange to represent assets and implement trust mechanisms. These technologies, working in conjunction, will serve as the foundation for new business and economic models, impacting major swaths of business and society. This is often referred to as the programmable economy. However, fully leveraging blockchain requires adapting and transforming core models, processes, and systems. These systems are literally the last place a business wants change to occur because of the large risk to operations. Addressing these business models and business value questions, preparing to adapt business processes, and implementing the technology will likely cause blockchain to take a decade to become significant in business transactions. Over the coming 10 to 12 years, there will be many advancements and setbacks in the blockchain space. However, the technology is expected to develop to the point where in the latter half of the 2020s, large-scale economic value will be created globally.